Hi everyone, welcome to the Homework 6 review video. Today I'm going to be going through all 6 of the problems in Homework 6, so let's get started with question 1, which is Lotto Max. Let's first read the problem description. So Kasturi has purchased a Lotto Max ticket hoping to win. She picked 7 digits from numbers 1 to 50, and this selection is in KNUM, which is a 1x7 vector. The winning draw is announced as a set of 7 numbers and a bonus number. And the winning draw is stored in a 1x8 vector called WinNum. The bonus number is located as the last digit in WinNum. So to win Lotto Max, these are the rules. If you select numbers that match any of the numbers from the first 7, so not the bonus, you're eligible for a prize. If you select the numbers including the bonus, then you're eligible for a prize. If you select the numbers in the exact same order as the first 7 numbers, you are eligible for the max million. And so what we want to do is create a function called Lotto Max that takes 2 inputs, KNum and WinNum, and has 3 outputs. A matchnum is bonus max millions. Matchnum is a double output that gives us the total number of numbers that we're matching from Kasturi's ticket to the winning ticket. Is bonus, which is a logical one if Kasturi selected the bonus, and false if she doesn't. And max millions, which is a logical value, so either true if Kasturi is eligible for max millions, or 0 if she is not. So let's take a look and start writing our code for this problem. So first I'm going to start out by writing my function. In this case, the syntax for the function hasn't been given to you, so you may have to do a bit of thinking about how we are going to write this function. So let's start out with our word function. And we know that it's going to have 3 outputs. Matchnum is bonus and max millions. So I'm going to write out my outputs first. And oops. I always forget. We can't copy from the given script or from the text. So let me write them out. Matchnum is bonus and max millions. And that's going to be equal to our function name, which is Lotto Max. And that has 2 inputs, KNum and WinNum. Okay, so now we have our function. Oh, sorry, this should be WinNum first and then KNum after. Okay, so let's take a look and first figure out the first output, which is matchnum. And so what this is telling us is we want to count how many numbers are the same within, let's say this is WinNum and this is KNum. So we want to see how many numbers are the same, and they don't have to be in the same location. So for example, here we have 2 in both WinNum and KNum, and we have 5 in both WinNum and KNum. So our answer for matchnum would actually be equal to 2. And so what we can't do is we can't just say WinNum equal to KNum and then count that, because this equals operator is just comparing directly element by element. So it would give us in this case 0 in every location because there aren't any 2 numbers that are in the same location and have the same value. So instead what we can do is we can create a loop that will loop through WinNum and see Okay, let's say we're on the first loop, we're on element 1, we can see if this is equal to any of the numbers in knum. And then we can go to the second digit and see if any of if this number is equal to any of the numbers in knum. And we can count how many we have that way. The other important thing to remember is that winnum actually has one more digit than knum. It has this bonus number 2 at the end. So what we want to do is we actually only want to go through, in the case of our example, the first 7 numbers. Here in the example I've made, it's the first 5 numbers. So we don't want to include the last digit of winnum when we're comparing numbers, since this is the bonus, and we'll check for this later. So let's write out our script for for matchnum. So I'm going to initialize it with 0 since it's some scalar output, and I'm going to use a loop. So I'm going to go and I'm going to say I is equal to 1 to 7, since my knum has 7 numbers, but my winnum has 8 numbers, but I only want to check the first 7 of them. I don't want to check the bonus number because I'll be checking for that later. So what I want to do then is I want to see if the element of winnum is equal to a digit in knum, then I know we have the same digit in both winnum and knum, and so then I want to add 1 to matchnum. So what I can do is I can say matchnum is equal to matchnum plus, and what I'm going to do is I'm going to say, I'm going to use my any built-in function, and I'm going to say if knum is equal to winnum in the ith location. And so what this is doing is saying, okay, if my winnum in the ith location, so this is one number, and it's going to compare this number to each element of knum. And where it is equal, it'll give a 1, and where it's not equal, it'll give a 0. So in this case, in my loop, with what my code is doing, it will first compare 1 to each of these, and it'll output some logical vector. In this case, it would be all zeros. Then it would compare 2. In this case, I would have this as my logical vector, and it would go through and compare the rest. And then if we use the any function on this, what it's going to do is if there's a true value in any of these locations, that means one of my numbers matched. One of my numbers was the same in knum and in winnum, which means that is a win or that is like one matching number. So I would want to add 1 to match num. And because my output for any in this case is either a logical 1 or a logical 0, what I can do is I can add this to match num. Instead of saying if any knum equals winnum match num equals match num plus 1, I can just add this directly because this would be adding 1. This logical value would get implicitly typecast into a double, and it would get added to match num as my loop goes through. And so that is my answer for part A. Let me write this out. Or it's actually not labeled in parts, but I'll call this match. So I know what part of my question I was answering here. Let's take a look now at the next part, which is, before we do bonus, actually, let's do max millions first, since this one's a little bit easier. In the case of max millions, we want the first 7 numbers of winnum to be equal to knum exactly. So we want, in this case, to have a max million. Unlike the match num, which is counting how many numbers we're matching regardless of their position, we want the first locations before the bonus of WinNum to be exactly equal to KNum. So we want the element in the same, we want the element in its location to be equal exactly to the number. And so in this case, what we can do is we can compare WinNum exactly to KNum, because we do want the element to be equal and in the same location in both vectors to win a Maximilian. So in this case, what I'm going to do is I'm going to initialize max as false, and then I'm going to say if, and then in this case, all KNum is equal to WinNum, and then we just want to check the first to the seventh numbers, because the last one is a bonus, which we'll check for later. Then Maximilians is equal to true. So in this case, oh, I'm missing a bracket. So in this case, if we do the operation KNum is equal to WinNum 1 to 7, these are both arrays. These are both 1 by 7 row vectors. And so the output of this would be again, a 1 by 7 logical vector. And so we're going to use the all function. If all 7 of those elements are equal to true, that means KNum has all of the same elements as WinNum and in the same locations, so that would be a Maximilian win. So that's why we use the all function, and now we're saying Maximilian is equal to true if this is the case. If this is not the case, Maximilian would remain as false. All right, let's now figure out the bonus. So in this case, we know that again, isBonus is going to be a logical output of either true if you have the bonus number somewhere in your somewhere in KNum, and false if you don't have the bonus number anywhere. So again, I'm going to first initialize isBonus as false, since it's either going to be a true or false value. And then what I'm going to do is I'm going to say if any. And what I'm going to do is I'm going to compare KNum. I'm going to say KNum is equal to WinNum and end. And if this is the case, isBonus is equal to true. And so what this script is doing is it's comparing the last number of WinNum, which is the bonus number, to every element of KNum. So it would get compared to all 7 of the numbers in KNum, and if they are equal, you would get a true, and if they're not, you would get a 0. So this part right here is going to be a 1 by 7 logical vector containing 1 where the element is equal to WinNum and 0 where it's not. And so then if any of those are true, that means you do have the bonus number somewhere. So we assign isBonus to true, and then if this is not the case, isBonus would remain false. And so now we've solved all 3 parts. Let's run our script. And again, the outputs within the function aren't printed, only the ones in the script. And so in this case, we didn't have any Maximilians, we matched 2, and we didn't have any bonus in this random generation. So let's copy over our function into grader and see if we were right. So I will submit, and I passed all my tests. Let's move on to the next question. Let's get started on question 2 of homework 6, which is the candy store problem. We've seen this problem lots of times before, either the donut shop or the candy store. And so this is a familiar premise, but this time we are creating a function for this problem instead of what we usually do. And so in this case, again, we have 10-digit numbers for each customer, and there are 500 customers. 6 of them can win if their 10-digit number satisfies a certain set of conditions. But in this case, so it's asking us to create a function, candy raffle, that has one input and one output to evaluate if the card is a winner or not. So the input in this case is a 1 by 10 vector containing a single card number. So the input is not the entire 500 by 10 matrix. It's just a 1 by 10 row vector that is one card, not all of them. And the output is winner is a logical value if the card that you inputted is a winner. So it just tells us, yes, this card is a winner, or false, this card is not a winner. And so this function is not asking us to count how many winners there are or find the index of them or anything like that. It's just asking us if we have a card as an input to find out if it's a winner or not based on the conditions. And so these are the conditions. The 4th and 9th digits are even, the smallest digit less than 3, 3rd digit not equal to 5th, 6th not equal to 7th, and then the sum of all the digits greater than 25. As we can see here in the given script, the given script actually does calculate who the winners are. So the prize receivers, it calculates the index of the prize receivers, and it calls the function that we're going to create. And so this script is given to you, and now we're going to need to create the function. So let's start creating our function. So our function is going to have one output is winner, and that our function name is candy raffle, and the input is card num. And so let's see, how can we design our function so that it can tell us if a card is a winner or not? So a card is a winner if it satisfies all 4 of the conditions. So if we write out, if we figure out if the conditions are true or false, and then if we find out if all 4 of those conditions are true, we know that this card num, that input, that 1 by 10 vector would be a winner. So I'm going to write out a variable for each of the conditions. And so what is our first condition? The first condition is that the 4th and the 9th digits are even numbers. So I'm going to use and then rem card num, and then the 4th digit. Remember again, card num is just a 1 by 10 row vector. So I'm just accessing the 4th element in this case. I want it to be even, so if it's divided by 2, the remainder should be 0, and then again, rem card num, and then we said we want the 9th digit to be even, so the 9th element, again, if the remainder is 0 when we divide by 2, we know it's even. That's our first condition. And our second condition is that the smallest digit is less than 3. So if we find the minimum number in card num, and so the minimum number will be the smallest digit in card num, and we want it to be less than 3. So that's our second condition. Our third condition is that the 3rd digit is not equal to the 5th, and the 6th digit is not equal to the 7th. Or is not equal to 7. And we'll use our and operator again, and we said we don't want, so the 3rd digit should not be equal to 5, and we want the 6th digit to not be equal to 7. And that's our third condition. Our fourth condition is that we want the sum of all digits to be greater than 25, so we're going to sum card num. Again, this is just a row vector, so we can just use sum directly. It'll sum up all of the elements, and we want that to be greater than or equal to 25. So those are all of our conditions. Now we want to calculate is winner. And in this case, because card num is just a 1 by 10 row vector, and we are performing these operations on them. Condition 1 to 4, the output of these is just going to be a logical vector, or a logical, just one logical value. So either true or false. If condition 1 is true, the output will just be a logical one. And we want all 4 conditions to be true for there to be a winner. So because it's just one single logical output, we're going to use the double AND operator. So we want condition 1 and condition 2 and condition 3 and condition 4 all to be true, for is winner to be true. And is winner should be, the output should be a logical 1 or logical 0. And that's what this output would give us. If all 4 conditions were true, then this output would be true. If one of the conditions if one or more of the conditions was false, then the output would be false, which is exactly what we want from is winner. Then when we run our code, as we can see, these variables don't get printed in our workspace since it's a function, but the variables in the script do get printed, and then we have some output for our prize receivers based on this code. All right, so let's copy our function and paste it into MATLAB Grader and see if we were correct. So I'm going to submit, and we pass all of our tests. Let's move on to the next question. All right, so the next question I'm going to go through is number 3, which is push odd numbers up. And this is really similar to the push zeros up from homework 5, except now we're doing it with odd numbers instead of with even numbers. So the premise is the same. We want the odd numbers to get placed in at the top of each column, and then the even numbers will go underneath in the same order that they were previously in the matrix. And so for each column, we want to bring up the odd numbers and place the even numbers underneath. And so what we can do is we can think about how we might accomplish this. So first, we would probably want to go column by column. Instead of working through the matrix all at once, we can go through each column using a loop, and then moving the odd numbers up within each column and go through the whole matrix that way. And then once we're actually in the matrix or in each column, what we can do is we can somehow extract the odd numbers from the matrix and get some vector that contains only the odd numbers, extract the even numbers from the matrix, get some vector with only the even numbers, and then we can concatenate them together vertically. So we would concatenate the odd numbers onto the even numbers vertically, and then we would get our desired outcome for the column. And we would just do that for each column. And what we can do is we know that we can use the rem function and a relational operator to figure out which the locations of the odd and even numbers. So if we found the location of the odd numbers, it would look something like this in the case of this vector, and then we would do another one for the even numbers, and then we can use this as an index for this column vector to extract the odd numbers, and then the same for the even numbers, and then we'd be able to concatenate them. So that's the thought process behind this problem and the logic that we're going to use to solve it. So let's start solving it. So first, I'm going to write my function using the same syntax that's provided in the question. So I'm going to write out function, and the output is new, and then the function is called odd up, and it has one input m, and that. And then the next thing we know is that if what we can do is determine which, we can create a logical matrix that gives us the location of the odd numbers. So I'm going to make a variable called isOdd, and I'm going to use the rem function. So rem, and then I need to use my input, so whatever matrix that will be my input. If I divide it by 2, I know if it's an odd number, the remainder will be equal to 1. So I use this logical operator, and when I do this, it will create a logical matrix that has the same dimensions as m, and it contains true where the number is odd and 0 or logical 0 false where the number is even. And then what I'm going to do is, I said I wanted to make a loop that will go through each of the columns, and it's going to go through the columns in isOdd, or it's going to go through the columns of m to replace the to push the odd numbers up, and we're going to use isOdd to figure out where the odd numbers are and to reference them and extract them from the matrix. So before I do that, I'm going to initialize my m new with the size I want it to be. And so what I'm going to do is I'm going to initialize it with zeros, and I want it to be the same size as my matrix m. So I'm just going to write in size m, and so now I have a my m new that's been initialized with all zeros, that is the same dimensions as my matrix m, whatever this input may be. And so this way I'm not hard coding. Here you can see my mat2d is a 10 by 10 matrix that will be tested when I call my function. But when I'm creating my function here, I want to create it generally so that it works for any size input of m when I call this function. And now we said we want to go through through each column of our matrix. So what I'm going to do is I'm going to create a loop that goes from 1 to, and I'm going to use size again. I'm going to do m, and I'm going to specify the size in the horizontal direction because that's going to count the number of columns. So this is saying I want to go from 1 to the number of columns that I have. So this is going through all of my columns, and that's why I'm using the horizontal direction for the size function, since that gives me the columns. And then what I know is that this gives me the a true where an odd number is located for the entire matrix. But if I want to figure out the location of the odd numbers for this specific column that I'm testing, what I can do is I can specify call, and then I'm going to reference my isOdd logical matrix, and I'm going to say I'm interested in all the rows and the ith column, since I want to work column by column. And then what I'm going to do is I'm going to say that my m new in that same location, so for that's the column I am looking at and trying to swap the, or trying to push the odd numbers up. Then what I'm going to do is I'm going to do what I said earlier. I'm going to concatenate the odd numbers on top of the even numbers vertically. And to do that, I'm going to use my call variable as a logical index in my original matrix m, and that's going to access my odd numbers. And then I want to concatenate that onto my even numbers. And what can I do to figure out my even numbers? Well, this is a logical vector that contains true where the number is odd and false where the number is even. But if I use the not function, then I am doing the, then I would find the opposite. Then I would have true where I have even numbers, and I would have false where I have odd numbers. So I'm just going to use the not operator, and I'm going to say not call. But do you see the mistake I've made while I'm concatenating? I've just used call as my index as a logical index in m, but where specifically looking at a certain column each time. We're working our way through all of the columns in our matrix through this loop. So here I also need to specify that I am looking through the ith column, since otherwise it would use linear indexing within my matrix M, and I'd always be looking at the same column, just a different logical array input, since this is going through each ith column. And so I need to specify that I'm looking at the same column as my as where I'm assigning those values in M new. And so this is just concatenating the odd numbers onto the even numbers. All right, let's run the script, and let's take a look at Mat2D and Mat2D test to see if the output is what I wanted. So here we got 45, 25, 3, and then next would be 13, 29, and so on. So I have 45, 25, 3, 13, 29, and so on. I have my even numbers here, 12 and 100, and I see here 12 and 100, so they're in the same order. So things look good for my outputs. Now let's copy the code I've written and submit it into Grader. And let's submit. All right, I've passed all my tests. Perfect. Let's move on to the next question.